Okay, yeah, let's just talk about the tech stack. Tech stack is, from a front end perspective, we're using React Native. It is a mobile app, and we wanted to deploy to both Android and iOS. React Native allows us to do that, writing one code base that allows us to deploy to both Android and iOS. Some other key notable things is, so the backend is built in Spring Boot. For user login and authentication, we are using Google Auth. Also going to be using Apple Auth. That's not here, but and one of the reasons for that is basically to be able to deploy to I'm forgetting the name, but the Apple's app market, you have to have both. If you're using Google, you have to also include Apple login. And another thing to note is, okay, our database is Postgres, and part of the application deals with documents. It's a service provider application. It connects people who need services with service providers. And what we do is we screen the service provider so that anybody who knows they need a service provider, they know that they're screened and they've gone through an authentication process, and they're safe to use, and they're reliable. So for that, the service providers have to provide a set of documents that we review on our side and we approve. So for holding the documents, we're using S3. And then, like I said, the database is in Postgres. So that's just, the high level tech stack. And so the first key feature set wanted to walk through is authentication. Go to do a walkthrough, just kind of like the diagram. This is a rough draft. We'll beautify this over time if necessary. So I'll go through this, and then we'll look at some of the code that implements into this. All right. So from a mobile perspective, right. So we're gonna have application deployed on the mobile phone, and then we're using Google Auth. And there's also going to be Apple Auth. Right now, Google Auth is what's implemented. Soon we're going to be implementing Apple Auth. But so in terms of authentication, I think this is to be helpful for people who might be new to authentication, and who might be new to the fact that if you're building an app and you want people to be able to log in, this is what really is going on behind the scenes. So okay, so our app, we're calling Google Auth servers to get an access token from Google Auth servers. In terms of our app, another key thing to note is, so our app is going to be issuing its own tokens, JWT tokens, but we're using Google in terms to leverage the fact that we want to make sure that they have a Gmail, that's actually working and that's actually active and it's already hooked up with Google. And so we can just leverage, that infrastructure versus having to build out that login of username and password tracking on our end. So we're going to get the ID, and it's called an ID token from Google Auth. And the reason why we're getting that ID token is because Google provides a endpoint that allows you to verify that the ID token is actually valid. So the mobile phone, when you're logging in, so the user selects their email, they log in, we get that response from Google. We take that response, which has an ID token. We call our backend, which has a endpoint that takes the ID token. It takes the ID token, it goes and validates with Google to ensure that the ID token that we got is valid. If it is valid, then we produce our own access and refresh JWT token. And we return that to the mobile app, the client, and then the mobile app saves that in secure storage. And again, thinking from a high level, so what's really going on behind the scenes? So we're using Spring Boot. So fortunately, Spring Boot has a lot of machinery that helps us deal with these tokens, in particular the JWT tokens that we're going to be issuing the client once we verify that they've successfully logged in with Google. So yeah, I'll show the code, but there's a security configuration that we set up with Spring Boot, and then so that's where we tell Spring Boot that we want to use tokens and then we also tell Spring Boot that we want a token every single time there's an API call, and then we're going to validate that, and then Spring Boot is going to help us validate that token based off the based off some beans that we configure. So we're going to configure an encoder, a decoder, and we're going to provide the secret key that Spring Boot should use to encode and decode. And so then, so whenever an API request comes in, it goes through our security config, it goes through our chain. Spring Boot ensures that the JWT token is valid, so it's signed properly. Valid essentially means that the access token and the refresh token that we provided the app was not tampered with. And if it's not tampered with and it's valid, then the person can communicate with our backend as necessary. Another thing to call out is when it comes to dealing with tokens. So typically the access token, which is what is used to be able to access the APIs, that has a expiration period. So when it expires, then it cannot be used anymore. And so we do have an endpoint also for a client to get a new access token using the refreshed token that we provide. So if they call that endpoint, they will be able to get a new access token again, as long as the token that they provided is valid. First things to look at is security config, basically telling Spring Boot how to handle authentication. And how you do that in Spring Boot is, you create a security filter chain, and just walking through that, we're disabling cross-site request forgery because we're not using cookies, we're using tokens. So that's not really relevant to us. We're setting sessions to stateless because we don't want to store anything regarding a user's login. We want them to be, in our case, we want them to send a token for every request, and we want to validate that token, the access token, in every request. Next up is we're basically saying, so these are some endpoints that don't need the access token. In particular, Auth is important because, for example, their access token might be expired. So we're just allowing these tokens to be accessed, these endpoints to be accessed without an access token, but everything else needs to come with an access token. And this is where we're saying that we want to be using JWT tokens. And then this is also Spring is going to know to look up to figure out whether or not we've configured a encoder and a decoder bean, as well as providing the secret key for the JWT tokens. And if we've done, it's going to use that. It's going to use those to validate tokens that it receives. And just looking at those encoders, this is where we create the encoder and decoder and provide the secret key. These are beans, so then Spring Boot is going to have that. So that's from a configuration standpoint, those are the key things. Then talking about when we're handling login, so first we need to validate the ID token. So we have a controller for handling that. We accept the request from the client, and we are calling Google to validate that ID token. So we can just look at that method real quick. That's making an API request to a Google endpoint that Google provides. And as long as, we're checking to make sure that the client ID for that ID token matches the client ID for our app. And then we're also making sure that the email, from Google side, Google has it, it's been verified. So that's simply that verification process. If it's verified, then we're going to go ahead and produce our own JWT token. We have a service to produce that. This is kind of like, Spring Boot machinery. We're creating our token, and leveraging the encoder beans that we set up. And I think that covers, authentication. We're going to be talking about just kind of the general layout of, the API, the backend. So it's Spring Boot, so we're following kind of the traditional setup. We have the controllers. So the controllers is basically the endpoints that we're providing people to be able to call. That's where we put our URIs. And then our controller then, in order to handle the logic, the controller calls a service method. So then the service method is where the actual logic for the endpoint is being done. Service methods typically provide leverage repository objects. Repository objects are what is used to essentially, what we're using to communicate with the database. And then in concert with that is model objects, which basically kind of mirror the tables in our database. So, that's typically what's happening. And then when it comes to the controller, then returning data back to the client, that's typically, we create data access objects for that. So just to basically the type of JSON that we would return back to the client, we have an object for that. And then in terms of actually looking at the code, you can see, that's how things are set up. So you can see there's a controller folder, and then in the controller folder, if we go into that, you'll see the different endpoints that we have. In an endpoint, you'll see that a service is being leveraged, a service method is being leveraged. If you go into the service method, you typically will find that there's a repository then being method. So pulling data from the database. And then you can see that the data we pull from the database is going into a model object that mirrors the table that we're getting the data from. And yeah, that's the general workflow. Another key thing to call out is on our controllers. So we've talked about this auth setup. So every endpoint that, doesn't have that pass in the security configuration, Spring Boot helps. It takes the token from the client and it injects it into all our controllers. So then we can access that token. And that's helpful because the token contains it contains details, for example, user details that we use to make sure that, for example, we use that for authorization purposes to make sure that whoever sent the API request actually has access to the endpoint and to the data that they're trying to access. For example, you can see that we're pulling out a user UUID from the token, and we're using that to actually find the user in our database. And depending upon the role of the user, for example, they may or may not have access to something. Next up is something I thought was pretty interesting, and it was cool to understand and figure out, was how notifications work with mobile phones. And we know, using EXPO has a notification service that lets you send notifications. And so I'm going to walk through kind of the setup and then what happens to actually send a notification. So from the mobile phone perspective, you have to set up notification listeners. So there's a listener for when you receive a notification, and then a listener for when a notification is tapped. And that's where you put the logic for what to do in those either situation. But in order to, so the process for notifications when it comes to EXPO services and mobile phones is you get a push token from EXPO notification services. So in our flow, and I think typical flows, is basically you get that token at startup. You get that token when you need it, right? So in our case is when a user is logged in. So either they're already logged in and they open the app, or they just log in, or they were logged out and they log in. So then we get the token in either of those cases. And so with that token, then we store the token in our table. And then I found out that in some cases there could be some weird reasons why, like somebody's account, they could have multiple tokens. Like maybe for some reason they switch phones, right? It's the same account. So that account could have multiple tokens. So we always check this. We always check the token produced by the phone, and we always push that token and we store it. And then in terms of sending notifications, so what you do is, so then EXPO also has an API for you to send notification, and so you send a payload to notifications to the service, including the push token. And then in terms of like a mobile phone, what you do is for a user, you check how you basically all the tokens you have stored that are active, you're gonna send a notification to all those tokens because you don't know which one is the actual, you don't know what device the user could be using. So you send that payload to notification services that then will send the notification to the device, and then using our listeners will process the notification. Now, in order for us to confirm whether or not the device received the notification, there's also a service, an API endpoint from EXPO where you get it's called push receipts, and then you get a receipt for each notification that you sent. And so yeah, you check the receipt for your notifications to check the status. And then one thing that's important to recognize is in some cases, there's something can happen basically where a token is disabled and a device is disabled, in that no notifications to be sent to the device anymore. So when getting the push receipt, we need to check to make sure that a device is not disabled from a notification perspective. If it is disabled, then what we do is in our database, we mark that token as inactive so that we won't send any notifications to it anymore. So that's it from a high level perspective. Looking at the code, let me pull that up. So I talked about, to get a token, there's an EXPO service provided in React Native that allows us to get that token. I've wrapped around that. There's a method wrapped around that to get the token. So, I'm not going to go into all the code, but basically, we're getting the push token, and then we're pushing that to our endpoint that stores tokens. So that's what's happening in the front end in terms of getting a token. And so then I talked about the two cases where we're trying to get that token. Either the user's already logged in and they open up the app from it being closed, or they log in successfully. And so then we're also calling this service to produce the token and store it in our database when a user is logged in, which means that the access token or the refresh token is valid. The one that we have stored in secure storage. That kind of wraps up. And then, we have the listeners. The listeners we also have in context, because that's the first thing that loads with our app. And so then, we have the notification received listener, which is when we receive a notification. And notification is called a response received listener. That's when the user taps a notification. From the backend perspective, so when the token is produced, our client calls the register endpoint, sending the token, and we store it. And then when we want to send a notification, oh no, I have a misspelling. When we want to send a notification, we're using EXPO services, and we're sending a payload, to EXPO to help us send a notification. From a backend perspective, so when a token is produced, we store that token, and so the client is going to call our register endpoint, and then from that point on, a lot of the work happens in the backend. So depending upon an event that happens, right? If somebody gets approved, so a subscription is enabled, then we know to fire off a notification, and so we have a service to fire off those notifications. Calls EXPO services, it sends a notification. If we have a situation where we need to send a notification, we do that. And then the other case I talked about is checking the status of a notification, which is pretty important because a device could be disabled. And then so we have a call, we have a service where we're tracking all the notifications that we sent, and we're essentially tracking the status of that. We have a table, and then we use that to know what to pull. Before we send a notification, we store that event in our database, and then we know, because we have that stored event, we know when we need to
fetch push receipts. We know what notifications we need to fetch push receipts for.
And then we check the status of the notification. And if successful, we have no need to keep the status, at least for right now. We might change that in the future. If it's not successful, currently we keep the error response so that we can analyze and address the issue. Is uploading to S3. So one of the key things that we do is basically service providers have to upload some key documents that we review in order for us to determine whether or not they can be on our platform. So we store those documents in S3. We also have a table. So S3 is where we store the file, and we have the path to the file. And in our table, we have a table where we store the paths to those files for each service provider. So just, walking through it, for S3 and storing things in S3 from an API perspective, you need a pre-signed URL. That's what allows you to, get or put things. So in order for us to upload, we have to get a pre-signed URL. So we have a backend endpoint that the client is going to call to get that pre-signed URL for that object that they want to put into S3. Then our backend calls AWS3 to get the pre-signed URL. Then we return that pre-signed URL to the client, and then the client uses that to put the object into S3. And then we also then have that the client is going to call a endpoint in our API to confirm that the item has been uploaded to S3. And that's how we store what's in S3 and know the mapping. So yeah, that's it from an upload perspective. And then also we have that a person who's looking for a service, they can see some of those key documents from a service provider. So that requires us to be able to download those images or those objects from S3. And the process is basically the same thing. But instead of getting a put URL, we get a download URL from AWS and S3. We return that download URL to the client, and then the client is able to download the object from S3. And just a quick walkthrough of the code. We can go through the front end and the back end side. So the uploading of the documents, simply put, so for example, in our app, the person selects the documents using their phone, and then we get access to the URI of the document within the phone, and then we just call our endpoint. So this is us getting the pre-signed URL for the document, and once we get that successfully, we are able to, we're doing a put. We're doing a put to S3 of the actual document, and then once that's successful, we do a post to our backend to confirm and to document the document we just pushed. From the backend perspective, so we have a pre-signed URL for uploads, so that's what the client is calling. We have a service for that. So we have a service where we create the URL essentially, and that's using AWS's API. We're using AWS's SDK to, this is how just following what AWS wants you to do. We're doing that. Turns the URL, and we're returning that back to the client. Then in terms of the put, that's calling AWS directly. And then the confirmation is making an insert into our database, the S3 file path. And some other information like the doc type and whatnot. So that's from a download perspective, similar process, just that there's not going to be a put. We're calling endpoint to get the pre-signed download URL, and then we return that, the download URL, and then the client gets that and then downloads the objects that it needs.